Hello students, I will be briefing you about one of the courses in the basket of professional elective 4, and that is CE 411A Structural Dynamics. It is 2 plus 1 3 credit course. 2 credits are allotted for theory, 1 credit is allotted for lab. So we will be meeting for 3 hours per week for theory and 2 hours per week for lab. I will be your course instructor. Have you ever wondered how do structures respond to dynamic loads? So quickly, I will show you a small clip. As you can see, there are three different structures of different heights mounted on a table. The table mimics the ground. As ground moves to and fro during the earthquake, the table also will move to and fro. You can see when the frequency of to and fro motion of table is around 4 hertz at that time, the tallest structure is exhibiting highest deformation at the top. The frequency of table's motion goes on increasing at around 6.35 hertz. The middle structure starts having the highest response. As the frequency of to and fro motion of the table is further increased at around 11.35 hertz, the smallest structure has exhibited the highest response to the table motion. What do we understand from this experiment? The response of the structure is driven by two things. One, the characteristic of a structure itself and characteristics of ground motion. In this course, therefore, we are going to answer few questions like how do a single degree of freedom system or a multi-degree of freedom system respond to a seismic excitation or earthquake excitation. If you look at the first structure on the left, that is elevated water tank, most of its mass is concentrated at the top, whereas the stiffness is concentrated along the columns. Such kind of structures are called as lumped mass systems, and if there is only a single lump mass, that is single degree of freedom system. Whereas if you look at the next picture here, the mass is concentrated at floor levels. So there are total 3 floor levels here. So mass is lumped at 3 different levels in this particular case. Such system is called as multi-degree of freedom system. So in this course, we are going to learn about how do we predict the response of single degree of freedom systems and multi-degree of freedom systems to various dynamic loads. Are there any prerequisites for this course? Yes, there are a few. Those are listed here. Newton's second law, stiffness matrix method of analysis of structure, solution strategies to linear differential equations, and eigenvalue problem. These are the prerequisites that we will have for this course. If these prerequisites are not in place, we are going to have a quick revision at the beginning of the course. So don't worry about it. Try to read about these 4 concepts. If you need the syllabus of the course, please message me personally on my WhatsApp number. Thank you.